In this video, we're going to talk about nucleophiles and electrophiles. So what exactly is a nucleophile? A nucleophile can be an atom or a molecule that bears a negative charge. And specifically, it is a negatively charged molecule that likes to give away electrons. It has a lot of extra lone pairs that it can give away. But these nucleophiles don't necessarily have to be negatively charged atoms. They can actually be neutral. So for example, water can act as a weak electrophile because the oxygen atom in water is partially negative due to its higher electronegativity compared to the hydrogens. And it also has two lone pairs that it can give away. So it can give away those electrons. Some more examples would be if you have hydroxide, or if you have ammonia, can also act as a weak nucleophile because of the lone pairs it can give away, and hydroxide has 3 lone pairs that it can give away. Another example of a weak nucleophile can be methanol, because even though it's neutral, the oxygen can give away the 2 lone pairs, or one of its 2 lone pairs. Now, electrophiles, on the other hand, are going to be things that can receive electrons. So an H plus molecule is going to be able to receive electrons. And also, in organic chemistry, you're mainly going to see carbocations, carbons that don't have enough electrons. They are also going to be able to attract those electrons to themselves. They're going to be able to receive electrons, which means they're electrophiles. So usually in reactions, what happens is that the nucleophile has extra electrons that it can give away, and the arrow is going to point from the electrons of the nucleophile toward the electrophile. So let's go over a few examples in organic chemistry. Let's say we have chloride. And let's say that's the nucleophile. And let's say we have a carbocation. What the chlorine is going to do is go ahead and attach to this positively charged carbon atom. The way we denote this using these arrows is that we want one of its lone pairs of chlorine to be pointing toward the carbon that is positive. And the result that you get is going to be chlorine attached to that carbon. And the chlorine previously had 4 lone pairs, but it used one of the lone pairs to form this bond, so now it has 3 lone pairs as opposed to 4.